definite integration అనేది. homework kanan දෙක තුනක් දුන්නානේ 2000 program tapodi wala ඒක බලන්න ඕනේ. ප්‍රතිපන්න 2000 you can do it easy. What deep question? Try your demo. By parts. Good evening, everybody. So last day we started definite integrals, and the theorem we did. Theorem, it's not in fact a theorem, it's like an extension of a theorem that we did there. The integration by parts formula, how to use it for definite integrals. Normal formula is this, what we learned at the beginning. U dv by dx equals uv minus integral v du by dx. This is the formula for integration by parts we learned at the beginning, some 2 weeks ago, maybe 2-3 weeks before. Now last day we learned how to like adjust this to find definite integrals. When you have limits say from a to b on left, then you will have to adjust this, apply limits on right also. This will change to uv from a to b, and the other part here you have to integrate first and then apply the limits. First integrate and then apply the limits, right? So this is what we did last, and one example we did here, and I gave about 3 for homework. The first 2 are easy, third is also easy, but it's from a past paper. You'll see that's 2000, year 2000. Question from year 2000. You are given I equals 0 to pi by 0 to pi e minus 2x cos x. I 2000. I equals 0 to pi e to the power minus 2x cos x, and j equals the same range from 0 to pi e to the power minus 2x. This time it's sin x with dx. You are asked to show there are two relations that we have to obtain. One is I equals to j. I equals to j, and the other is j equals 1 plus 1 plus e to the power minus 2 pi minus 2I. Right? Okay, so let's just apply that formula to find, say, I. Start from I. I equals I equals 0 to pi e to the power minus 2x cos x dx. Applying the formula, take this as u, this as dv by dx, then du by dx will be equal to minus 2e minus 2x, and v will be equal to sin x. Right? So the formula is u dv by dx a to b equals uv a to b minus v du by dx a to b. Is the formula. These things are like after. So applying the formula, you get uv. U is this. U is e to the power minus 2x, and v is sin x as x goes from 0 to pi. X goes from 0 to pi minus v du by dx. Limits 0 to pi. V is sin x again, and du by dx is minus 2 e to the power minus 2. If that will make it plus here, you can take 2 out. E minus 2x dx. Right? What happens? Abhita, good evening. What happens as we apply the limits here? What happens to this? When x is pi, you get sin pi. Whatever the value of this, with sin pi, that becomes 0. Right? It becomes 0. 0 minus, when x is 0, again sin, whatever the value of e part, the sin part is, sin 0 is 0. So again it's 0. Plus 2 times, and what is this? What is this? XP. It's J. So you get the equation I equals 2J. Equation number 1. ඔය වගේ ඊළඟ එකත් පෙන්නන්නකෝ. Start from J and find this. ටක් ගාලා විනාඩි දෙකක් දෙන්න. Good evening, Satin. We are discussing year 2000 question paper. Question number 5, part B. This is the first part. You have to show that I equals 2J. I equals 2J in one line, 2 lines. You get the answer. ටක් ගාලා විතරක් කරලා. அது tricky one. Similarly, you can prove this also. Oh, board එක ගොඩක් ලොකුයි නේද? කවුද අභිත්? මම අලුත් කැමරා එකක් ගත්තා. අලුත් කැමරා එකක් ගත්තේ මේ ඕකලොගේ ඔන්ලයින් ක්ලාසස් නම් ඉවර වෙන ළඟයිනේ දැන් නේද? අපිට පටන් ගන්න පුළුවන් මේ normal classes. මම ගත්තේ මම lessons ටික දැන් ඔය ඕකලොන් පන්තිවල ගන්න නේවනේ වීඩියෝස් ගන්නේ YouTube එකට. ඒකට ඒකෙන් ඇත්තටම වැඩිපුර ප්‍රයෝජනයක් ගන්න පුළුවන් ඔයගොල්ලන්ට විතරයි ටියුට්ස් ප්‍රශ්න ටියුට්ස් දීපු අය මම උත්තර දෙන්නේ මම ඇත්තට දැන් මේ පිළිවෙලකට කරලා දාන්න හිතන්නේ අලුතෙන් වීඩියෝස් ටික මට වෙලා තියෙන විදිහට වීඩියෝස් ටිකක් නෑ ඇත්තට වීඩියෝස් හදලා දැන් මම ක්ලාස් එකේ ඉන්නවා YouTube එකට දාලා වෙනම වීඩියෝස් හදලා දාන්න හිතන් ඉන්නේ දුර පළාත් වල ළමයින්ට වැඩි ප්‍රයෝජනයක් ගන්න පුළුවන් ටියුට්ස් ප්‍රශ්න ඕම එක අයියා ළඟද ඒක නිසා පොඩි අත්අඩංගුවෙන් ටිකක් කරනවා මේ දවස් මේ මොනවාද ඔඩියෝ එක හොඳයි නේද අහනවා අවුලක් නැහැ නේ පෙන්නා වගේ අහනවා නේ අලුත් මයික් එකක් තියෙන්නේ වෙන මයික් එක මට පාවිච්චි කරන්න පුළුවන් මේ අකුරු පොඩි අකුරු පේනවා ප්‍රශ්න නැහැ මේ කැමරා එක කලින් එකට වඩා ෂාප් අකුරු පේනව නේද ළමයි මම කියන දේවලුත් ඇහෙනවා වෙනදට down right එහෙනම් හොඳයි මම විශේෂයෙන් දුර පළාත් වල ළමයි අධ්‍යාපනය යන කියලා තියෙනවා ඒකම දෙය මට මේ වෙලාව තමයි ප්‍රශ්නේ වෙලා තියෙන විදිහට දැන් මේ සතින lessons කීපයක් කරලා දාන්න so to find J you get that for J let's take this as you UV U to the power minus 2x V minus cos x from 0 to pi minus 0 to pi v du by dx. V is this, right into that, that will become plus cos x du by dx, again minus 2 times minus e to the power minus 2x sin x dx. So this is j, isn't it? Hmm? And applying limits, then it is pi, cos pi is 1, cos pi is minus 1. This gives, taking minus 1 out, e to the power minus 2 pi, e to the power minus 2 pi, cos pi is minus 1. Minus, then when it is 0, e to the power 0, cos 0 is 1. Minus 2j. This is just 1. 1 minus e to the power 2 pi. 1 plus, with minus, then become plus again. 1 plus e to the power minus 2 pi minus 2j. Isn't that what we need? Yes, exactly. Equation number 2. And this is equation number 1. This is rather I, isn't it? This is I. No. Oh, whatever. I'm going to cos x. This is cos x. This is I. So you have two linear equations now. Now there onwards it's OLMS to solve two simultaneous equations. Then solve them. You asked to evaluate I and J. Just solve the two equations, simultaneous equations. So we have proven the two results. Now we have two linear equations of I and J. Solve them. I can substitute for this I from this. Substitute from 2 in 1, from 1 in 2. You get J equals 1 plus e to the power minus 2 pi minus 2i. 2i. That will give minus 4j. So altogether j will be equal to 1 over 5, 1 plus e to the power minus 2 pi. Okay. And from this, I is just the twice of that. You multiply this by 2, you get I. I is in 2 over 5, 1 plus e to the power minus 2 pi. So, yeah, that's it. Right. So we learned some technique, right, to find to use the the formula of integration by parts in definite integration. Okay, uh, like an extension of what we have done earlier. That's another thing. Similarly, another extension. Earlier we learned another method of integration by changing the variable or using substitutions, right? Earlier we solved problems of integration using substitutions, but only indefinite integrals, right? Now, how to use that to find a definite integral, right? To evaluate a definite integral, how to use substitutes. So that's something also that we have to convert into this. So that's what we are going to do next. What do we do when we use a substitute to evaluate a definite integral, right? We know very well how to find the indefinite integral using a substitute, right? Uh, Indefinite integrals using substitutions. Indefinite integrals using substitutions. Right. Uh, Now suppose that we use the substitute t, some substitute t to find the indefinite integral, some indefinite integral, say integral of fx dx, as we have done before. Fx dx, right? So we are using the definite the substitute to find this indefinite integral. So with the substitution, this will convert into something manageable, right? And and it converts into some other integral in terms of t. So fx dx integral converts into gt dt with the substitution. So you know how to find this, right? By now, we some 3-4 weeks before we said this, and several models, methods, standard substitutes. We did a lot, right, about this. Now the thing is, this is the indefinite integral. What if it's the definite integral? You have some limits here. Now, if we have to evaluate the definite instead of the indefinite integral, you have to find the definite integral. Definite integral as it goes from a to b. The same function, but with limits. Now that means we have to apply some limits on the other side also. Fx dx converts into gt dt with the substitution, right? Now, if we have limits on this side, what do we do? on the other side. What did I? What do you do? Same limits, A and B. On the other side, M did I? You just write A and B on the other side also? Hmm? What do you do? If it goes from A to B on this side, here also you write A to B. If not, A, B are the values of x, where x goes. X goes from, as x goes from A to B. We find the definite integral here, right? But here the variable is t, not x. So do we just write A and B, the limits of x between what x behaves? No, you have to write new limits on right, new limits. How to determine it? As x goes from A to B, you have to find the corresponding limits of t. As x equals A, what is the value of t? As x equals B, what is the value of t? Likewise, on right, you have to apply corresponding limits of t as x goes from A to B, right? So as x goes from A to B, fx dx, to evaluate this, we have to adjust the limits as, this is what we do. The indefinite integral is this, fx dx converts into indefinite integral gt dt. As x goes from A to B, the new limits are not from A to B. This is the value of t as x equals A. That's what you are writing here. And here it has to be the value of t as x equals B. T as x equals B. Right? So the new limits will look like that. In other words, x goes from A to B. We find as x goes from A to B, where t goes from where to where. The interval of corresponding interval of t. Okay, so you have to do this adjustment. If you use a substitute to evaluate a definite integral, as මේ වගේ තමයි වැඩිපුර exam එක දාන්න ඕනේ exam paper එකේ මම වැඩි past papers වලින් ගණන් හදන්න ඕනේ නැත්තේ ඒකයි අදන එකක් ඇදී past papers වලනේ definite integrals mostly they ask example, say you have to find x into x squared minus 1 to the power 4 dx as x goes from say 1 0 to 3 no 0 to 2, right? Now without the limits you know how to find the indefinite integral. Question is this, evaluate this, right? Answer, we use, this is what we have to find. We use a substitute for this, db equal to x squared minus 1, then dt will be equal to 2x dx. These things we have done earlier. Then you find something to replace this x dx in terms of t. X dx is equal to half dt. X dx will be replaced by half dt. Now this that's all we found earlier in definite integers. Now in addition to this, we have to find new two limits here. The new limits also. So let's find them. As x equals 0, what happens to t? Also, t equals what? When x is 0, t will be equal to minus 1 as x is 0. And as x is 2, as x is 2, t will be equal to 3. And now we can substitute. Now we can substitute as a whole. As x goes from 0 to 2, x into x squared minus 1 to the power 4 dx. So x squared minus 1 to the power 4, it's t to the power 4. X dx is half dt. Now new limits. As x is 0, t is equal to minus 1. Here we write minus 1. As x is 2, the t value is 3. We write 3 here. Now the rest is easy. You can integrate. I'll do t to the power 5 over 5 as t goes from minus 1 to 3. So now we can substitute the values. Now you don't have to go back and replace t by this. We are looking for a definite value of the definite integer. So just substitute new values, you get the definite integer. Earlier after this stage, we went back and replaced t by this x. Now here you don't need to do so, right? You just apply the limits. As t is, I can take 5 out, 1 over 10. As t is 3 to the power 5, 243, isn't it? Minus as t is minus 1, there will be plus 1. So 244 over 10, you can divide by 2. 122 over 5 is the answer. Huh? What we do when we use a substitute to evaluate definite integer. Is that clear? So we'll do 1 or 2 more examples. Right. Okay, I'll write one more example here. Then පාඩම අමාරුවාදී ඉවරයි කන්න දැන් මේ ටික කරලා දෙලින් පාස් ප්‍රොසෙස් කරනවා. Example 2, find say root of 4 minus x squared dx as x goes from Okay, guys, is that clear? What we do here with the limits when we use a substitute. What is the substitute that we use in a problem like this? Some standard substitute. Yeah. No. Mukti kya naam hai? What do we use to solve a problem like this? What is the substitute? Hari demikian. Berarti. Not too sec. Not too sec. अभी तक it's a square minus x square. You take sec, then it is x square minus 4. For x square minus 4, it's 2 sec. For 4 minus x square, it has to be not 2 sec. It has to be x equals to sine. हम तो बनाने इतनी निक करना पड़ता है मतलब ओ दादा ने दे भी बोला पहले दान तक oh I don't want to do no problem. It has to be to sine. Oh, even cos is possible. Now the new variable is theta, okay? Then dx, you have to find dx, that will be 2 cos theta d theta. And further you have to find the new limits, new values of what? Values of theta, not sine theta. New variable is theta. When x equals 1, you get 1 equals to sine theta. Sine theta equals half, so theta will be equal to pi by 6. When x is root 3, you get root 3 equals to sine theta. Sine theta equals root 3 over 2. Theta will be equal to pi by 3. The new limits are pi by 6 and pi by 3. So substituting new limits are pi by 6 to pi by 3. So you get from pi by 6 to pi by 3, 4 times cos square theta d theta. Hmm? Cos theta into cos theta, cos square theta. No, there's another 2. 4 times cos square theta will be written as 1 plus cos 2 theta divided by 2 d theta. That's 2 times theta plus sine 2 theta over 2 pi by 6 to pi by 3. So it's pi by 3 plus sine 2 pi by 3. It's the same as pi by 3. Root 3 over 4. Then pi by 6 minus pi by 6 and sine pi by 3. Will be again root 3 over 4. Make happen on it, root 3 over 4. Right, sorry. 2 pi by 3 sine pi by sine pi by. You can happen on it. Ultimately, you get pi by 2 into 2. That means pi. Okay. So one last thing in integration. Hmm, After a long time, after a long time means we have been in this for a long time. Hmm. We are going to see the end of this integration. But the thing is, the last theorem, it is of that they have asked the proof many times in last few years. You need to know the proof of this theorem, right? We did three theorems earlier. Theorem 1, 2, 3, then stop theorems. Then I learned how to use by parts indefinite integration. Then we learned this one, how to use substitutions in definite integration. Now going back to the last theorem, theorem number 4. Hmm. Uh, of this, you are expected to know the proof by heart, right? They ask it very frequently. They ask it, especially in last 10 years. Hmm. They have asked that earlier for higher maths. Only now ask in combined maths also. Uh, Data problem. Long cut data, internet speed. Right. Before going to the theorem, I want to give some other result because that result we using the proof of the theorem, right? Better you know this before the theorem, you write as a note. So even though x and t are two different variables, right? X and t are two different variables. You integrate fx as x goes from a to b, right? You integrate fx as x goes from hi Sharad, uh, as x goes from a to b, then you find again this is of x, right? If t dt between the same two limits a to b, between the same two limits, you find ft dt. What do you think? The results? X and t are two different variables, right? Once we find a to be fx dx, then we find a to be ft dt, same function but different variable, but the limits are the same. What do you think? What do you think? Finally, results are the values are the same, right? Not sure. Without it, so let's prove. Hmm? Prove it. So this is not the theorem that we are going to learn, right? We are going to use this in the proof of the theorem. That's why I'm giving it now. Proof, say, let the indefinite integral of fx dx be some gx. It's a two-line proof. Mhm. Let the indefinite integral of fx be gx, right? Then you find the left-hand side, definite integral a to b fx dx, that will be equal to gx as x goes from a to b. And finally, this is equal to what? Final the value to evaluate this, you apply the top value. So that will be equal to GB minus then the bottom value, GB minus GA. Right? Then what is the indefinite integral of FT? FT dt? Yeah, that will be GT. So similarly, you find FT dt, this one as t goes from A to B. So that will be equal to this time it will be equal to dt as t goes from A to B. Now what do you get? Exactly the same gd minus ta. So by 1 and 2, you can say this is equal to this. Hmm? By 1 and 2. Oh, better leave it there. Okay. Amazing. By 1 and 2, A to B, fx dx is equal to A to B, ft dt. Now, no doubt. Okay, take it out. Then we can go to the next theorem. අපි මේකේ areas and volumes පටන් ගන්නවාද? ලබන සතියේකට ඒක ඉවර කරන්න පුළුවන්. ඒකට calculus ලබන සතියේ. Okay, now we can go to the theorem. Hmm? Theorem is this. මේක නිකන් පොඩක් තේරුම් ගන්න ඊට පස්සේ ලොකුවට ගන්න එපා. It is not mentioned in the syllabus, but you need this to understand the proof. The theorem says, theorem 4, isn't it? Theorem 4. We did 3 theorems earlier. The fourth theorem, 0 to another result like that previous one. Q at can this be? But with the proof, everything cleared. No doubts. Now look at this. The theorem says you integrate from 0 to a, f of a minus x. 0 to a, f of a minus x. It is as same as finding 0 to a, fx dx. 0 to a, fx dx or 0 to a, f of a minus x dx. The values are the same. Sure, man. Now go. Huh? Even if monkey birth is come on, man. ආලාම සූත්‍රයේ බුදුහාමුදුරු කියලා දෙන්නේ තියෙන්නේ අම්මා තාත්තට ගුරුවරයා කිව්වා කවුරුවත් පිළිගන්නේ නැහැ. ඔයාලා බලන්න නැතුනේ. Okay, it's good. Then but we are going to prove it. I'm going to show that this side is equal to this side, right? So you can guess how I'm going to start it. Consider this one 0 to a f of a minus x dx. මේ proof එක මතක තියාගන්න ඕන ළමයි. මම ඉස්සෙල්ලා කිව්වනේ. කාලෙකට පස්සේ පර්ණයාගේ අටපාඩමින් තියාගන්න එපා. Right? You are expected to know this proof by heart. Okay, consider this, and we are going to show that it's equal to this. You can guess how am I going to start it? What's the technique? Can you guess? What am I going to do here? As to start? Yeah? No. Oh, you mean going to indefinite integers? No. Oh, Inaya, Abita, Sachin. What do you think? එක වචනයක් මට දැනගන්න. One word. In one word you can explain. Any idea? We use a substitute. Substitute for what? Next question. Substitute for? No. Substitute for a minus x. A is a constant. So get some t be equal to a minus x. Then we find dt. dt will be equal to minus dx. And further we need to find the new limits. As when x is 0, t will be equal to, when x is 0, t will be equal to a. When x is a, when x is equal to a, t will when x is equal to a, this t will be equal to when x is a, t will be equal to 0. So now I have everything that I need to substitute. Now substituting, you get 0 to a f of a minus x dx equals uh, f of a minus x will be replaced by t dx by minus dt. Minus 1 will come out, right? Minus dt. The limits as x is 0, t will be equal to a. Then as x is a, t will be equal to 0. देखो तो क्या है minus a to 0 ft dt. Now you can use the very first theorem, which says minus a to 0 is as same as the first theorem says minus a to 0, you can switch the limits 0 to a ft dt. 0 to ft dt. Now few minutes before we have seen that 0 to a ft dt of our previous proof 0 to a fx dx are the same. 0 to a ft dt or 0 to a fx dx, you get the same result. We have proven it. So that's the proof. තේරුණාද ළමයි? ඒ proof එක මතක තියාගන්න ඕනේ. ඔය ඉන්න ළමයි තේරුණාද? ඉන්න කියලා නෑ නේද? ඔක ලියාගන්න මම ගානක් දානවා හතරට. Okay, take it down and then try this problem. Okay. Yeah, in success, you don't need to prove. You have the tool to use. Ini use the theorem. The theorem says 0 to a f of a minus x dx equals 0 to a fx dx. So you can use it the other way around also, right? This equals that. Now the question is 0 to 1 x ex plus e1 minus x dx. The theorem says if you start from this side, you can replace x by a minus x. We are going to integrate from 0 to a. A is the upper limit, right? 0 to a, you are going to integrate from 0 to a. That means you can replace x by a minus x. So applying it here, applying this rule here, you can replace this x by everywhere. This x in the function x can be replaced by a minus x. So applying it here, this x can be replaced by a is 1 minus x. So we are going to replace x by 1 minus x. The theorem allows us to do so. Enables us to do so. So what happens now? You replace x by 1 minus x. See what happens? 0 to 1, x replaced by 1 minus x, e x replaced by 1 minus x plus e 1 minus, again x replaced by 1 minus x dx. Here x get cancelled. 0 to 1, 1 minus x. This is here 1 get cancelled. I'll write it, take it forward. Ex plus e1 minus x dx. So this is equal to this. Now I'm going to open these brackets. Just break it into 2. So you get 0 to 1 multiplying by 1, it will be the same. Then break it to 2. The next part I am going to take separately. 0 to 1 x into ex plus e1 minus x dx. What do you see now? What do you see now? This is the same as that. So the same thing we are getting here. So we will take it to the other side. Translate to the other side. So this will be doubled. So let's use 2 times 0 to 1. This will be doubled. X ex plus e1 minus x dx equals this part. 0 to 1 ex plus e1 minus x dx, and finally we'll just divide by 2. So finally you get dividing by 2, you get 0 to 1 x dx plus e1 minus x dx equals half divided by 2 0 to 1 dx plus e1 minus x dx. Now the thing is, you can easily find this side. Now, if you want to find this, the left hand side, you have to apply a, integration by parts. By parts, ටිකක් කරදරයි වැඩ වැඩි. Hmm? So now applying the theorem, it reduces to this. This is something you can find very easily. So find it and then finish. Hmm? ඒක ඉවර කරන්න එක තමයි සාවධාන කියන්න. You got to finish it. මේ ගාන ඇදුවම කොට මේ පාඩම ඉවරයි. Integration. Zero to 5 by 2 x times sin x plus 6 dx plus 0 to 5 by 2 half sin x plus 6 dx hence evaluate මේක ඉවර කරලා මේක කරන්න. level. So this is the first answer. And now is equal to Ex plus E1 minus x over minus 1. When you get when it is 1 E minus E0. E0 is 1 minus when it's 0 E minus when x is 0 when x is 0 E when x is 0 E1 මොකද වෙන්නේ is when x is 0 it's 1 minus 1 minus 1 Get a negative or kind of. When x is 1, you get E and minus. This isosceles. මෙතනනේ. ඔව්. අනේ ඉන්ටිග්‍රේට් කරනකොට මයිනස් වෙනවා. c to power minus 6. ඉවරට minus. නෙගටිව් වැලියු එකක් ආවොත් නම් මොනවද? මගේ පොතේ ගන්න මොන මතක මට හිතෙන්නේ නැහැ නෙගටිව් එකක් එනවා. It looks like they are going to get a negative. Let's check anyway. Looks like they are going to get minus 1 anyway. I think කැපෙන්නේ නැහැ දෙකම එකතු වෙනවා. මේ CC මේ දෙකත් එකතු වෙනවා. ENE 2E නේ. එතන්නේ මෙතන E minus 1 වෙන මේ තියෙන්නේ. plus E minus 1. So it's E minus 1. හරි හරි. මට වැරදිලා කතා කරනවා. These two will add and E minus 1 is homothetic is something around 2.713 minus 1 finally it will be equal to 1.713 around something around that. Anyway, you can just leave it like that and then go to the second. Kalian කරන්න දෙවෙනි එක. ඔක හරිද ළමයි තේරුණාද කරපු දේ? අභීත සකින් මොකද උත්තර නැත්තේ කාටි? How we use what is how we use the theorem and how useful the theorem is. Is that clear with the example? How we used it for the question? Yes. Okay. Okay, then you can try the next second. හරි කරගෙන යන්න. කලින් ඇත්තේ. හ්ම්. දැන් తీసుకోలేదు తీసుకోకుండా తీసుకోలేదు. మాస్ తీపే సంపూర్ణ. ప్రస్తుతం ప్లాన్. हम्म. सीखना ना कोई तरह निकाल प्रूफ है किस बात 0 to pi by 2 x sin x plus cos x dx. The theorem says you can replace x by pi by 2 minus x a minus x. It is so. So x is replaced by pi by 2 minus x sin of all x here will be replaced by pi by 2 minus x. It is like pi by 2, 0 to pi by 2, pi by 2 minus 6. Sin pi by 2 minus 6 is cos x, cos pi by 2 minus 6 is sin x. I take this forward, sin x plus cos x dx. Then open the brackets. Open the brackets. At the same time, I can take pi by 2 out. Sin x plus cos x dx minus then 0 to pi by 2 x into sin x plus cos x dx. So it's the same thing on left. We can take this to the other side. 2 times 0 to pi by 2 x into sin x plus cos x dx equals pi by 2 going out. It has to be not half. It has to be some pi by 2 or pi by 4. චුට්ටක් ඉන්න තමයි මම ලියපු ප්‍රශ්නේ වැරද්දක් තියෙනවා. It has to be 5 not half. It has to be pi by 4. මෙතන හදාගන්න not half. This has to be pi by 4. This has to be pi by 4. ඒක හදාගන්න. Let's finish it. Did you correct it here? It has to be pi by 4, right? And the question. This is the answer for the first part. Now you can this side you can easily evaluate. If not, you have to apply again integration by parts to this. But this is very easy. You can easily find it equals pi by 4 sin x integrate you get cos x plus cos x is sin x from 0 to pi by 2 pi by 4 the top sin pi cos pi by 2 is 0 plus sin pi by 2 is 1 minus and we apply this cos 0 is 1 that will be minus 1 plus 0. So finally it's 2 pi by 4 into 2. Finally the answer is pi by 2. Okay. Yeah. Right. ඔන්න integration ඔතනින් ඉවරයි යා. දැන් මම මගේ පොතේ ගණන් exercise දෙන්නේ නැහැ. You can straight away do a problem from past papers. දැනට 2010 ඉඳන් එහාට ටික කරන්නකෝ. ඊට පස්සේ 2010 ඉඳන් ඒවා ටිකක් කරා නම් හොඳයි යා. Moment homework from 2010 to 2020 ඊට පස්සේ අනිත් ඒවාත් කරන්න 2000 to 2010 පස්සේ ආයි කරන්න at least do this for this week right මොකද පාඩමේ ගොඩක් දේවල් තියෙන නිසා අමතක වෙන්න පුළුවන් ගණන් අද කොට අදකට ඒක හරියට දැන් ගණන් 300කට වැඩි හදවලා තියෙනවා මම මේ පාඩමේ Right, so the last topic in calculus, finding areas and volumes. We'll start by areas. Areas by integration. අද පටන් ගමු. අද මේක ඉවර කරන්න බැරි. හැබැයි දෙකම ලබන සත්‍යනට ඉවර කරගන්න පුළුවන්. කොහොමද ඉවර කරමු වැඩි වෙලා කරන්න යන පස්සේ. Areas by integration. The thing is, we can't explain this much because it's something coming with the definition of integration, right? As I remind you now several times, we haven't done the definition of integration integrals. Uh, in this class for A levels, we don't do that, right? Definition එක දැනගන්න නම් ඉතින් A level වලින් එහාට ඉගෙන ගන්න ඕනේ. The area, the concept of finding areas, that comes with the definition, right? So not an explanation, I'll just teach you how to find it. Find and find an area using definite integrals, right? And this is how we do it. Consider the function f of x and its graph y equals fx, right? Graph y equals fx. We draw the graph. Say it looks like this. Suppose that the graph looks like this. Right? You are asked to find an area. Area, what we say, under the curve. Area under the curve means this is the curve. Under the curve means area enclosed by the curve and x-axis. Area enclosed by the curve and x-axis between some two limits. Area enclosed by the curve and the x-axis between some two limits, say x equals a and a to b. This is the area that we need to find to evaluate the area enclosed by the curve y equals fx and ox-axis between x equals a and x equals b, right? So that's what you are asked to do. And in this method, what we do is we consider some column, some general column in this area at a distance x along x-axis, of which the width is delta x. Let's name it an AB column. We take some column like this. Right? Take some column AB at a distance x and breadth delta x, right? So at a distance x, the height of the column, this end is y, because it is y equals fx, the y value. This height is y, or fx. Height is y. You can, if you want, you can replace y by fx. පොඩක් ආගන්නක කරන වැඩේ, right? එච්චර දෙයක් නෙමෙයි කියන්නේ. හරිම හරියට කියනවා නම් this is at which the theory of integration born, right? But we are not able to explain it at this stage. It's a very beautiful thing, right? I told you before also the theory of integration discovered by the mathematician Riemann integrals. It's a very beautiful theory in mathematics. It starts from, in fact, something like this, right? Uh, but we are not able to discuss it in full detail. අපිට එතන ඉදිරියට පොඩි සෙල්ලමක් දාලා අපි අපිට ඕන දේ කරගන්න. හරි? Right. We say consider a column AB at a distance x from O along O00 along x-axis, measured along x-axis, right? So the column will say it looks like this. Delta x is the breadth of which breadth is delta x, right? So I draw it again. So it looks like this with the curve, right? AB, ABC කියලා දාමුකෝ. AB කියලා දාන්න මේක. So we took this height as y. This height as y. Right? So the problem is to find this area. Is it easy? We don't know the shape of the curve. Is it easy? No. It is as an answer for this problem. The theory of integration came into mathematics, right? So that theory, as I said, we are not going to discuss here. But what we do here is, we like take make it a difference, like cut it from this end. This end or from some end. Say from this end we cut it, right? So that will take this part off. Right? In other words, we made it a rectangle. Taking this part off, or you are going to neglect that part. Neglected part. If you neglect that part, so the area of AB column will be approximately equal to, right? So area of AB, column AB is approximately equal to, this is the height, this is the breadth. So it is y into delta x, isn't it? Now it's approximately equal to y delta x if you neglect this part, right? The theory is in fact about this neglected part. Now forget that for a moment, the part that we neglected. Then the total area that we need to find, the required area isn't it equals, that means you break this or partition this area with these columns. Partition, in fact, you are partitioning the x-axis. This area we break into these many such columns. So of any such column, the area is approximately given by this, right? We break this total area into many columns like this, and of any such column, the area is approximately given by this, right? So the total area that we need is the summation of such areas of columns, column areas. Got that, everybody? The total area that we need is the sum of these areas of columns. So that is sigma y delta x, y delta x, but you have to cover this only this area. This area is identified as y delta x, y into delta x is the approximate area of this. We are going to sum such areas as to cover this as x goes from A to B. So the summation we take as x goes from A to B. Right? Now, the theory of integrals says if the column is, if this curve is continuous within the interval AB, so this area, it is this area we find as the definite integral. So you replace this sigma, right, to find such an area, or to find such summation. If the function is continuous within that interval, it is this summation that we find as definite integral. Replace this by definite integral y dx. Delta x becomes dx. So පොඩි දෙයක් නිකන් කියන්න පුළුවන් මේක හරියටම හරිත් නෑ. So we neglected the part, right? To neglected the part to like minimize the effect of that thing. Minimize the effect of this. What do? මේක තව කෙට්ටු කරා නම් error එක අඩු වෙනවනේ. So this is the error, right? Neglected part, or it is the error. මේක කෙට්ටු කරා නම් error එක අඩු වෙනවා. That you make delta x much thinner. Delta x smaller, the column, you make the column thinner. The error will reduce. If you want to make the reduce as possible, as much as possible, what do? You will have to make delta x, one can be a very big one, as small as possible. To minimize the error, you have to minimize delta x as, you have to make delta x as small as possible. That means we send delta x to 0, or in other words, we are taking an infinite number of such columns. Delta x polyvenna, you are taking more and more columns. As delta x goes to 0, number of columns will go to infinity, right? So delta x, we are making it small as possible. Then delta x will become dx in the integral. Okay, so the area is given by this. Therefore, area is equal to integral of y x යාට දෙකන්නේ. y තියාගෙන x වලින් ඉන්ටිග්‍රේට් කරන්න බෑනේ. So finally we replace y with fx to take it in fx. Y is replaced by fx as x goes from A to B. So the area is finally given by this definite integral. The function is, the graph is of y equals fx. We want to find the area under the curve as x goes from A to B. In short, it is directly given by the integral of this function as x goes from A to B. So that's what we found finally. Right? In short, that's what we found. And this is the story. මම මොකද තේරුණාද කියලා අහන්නේ නැහැ. මොකද තේරුම් කරේ නැහනේ. මෙතනින් මෙතන පයින් හැටි. ඒක තමයි theory of integrals. දැන් ඔය මූලිකව කියපු කාරණේ තේරුණානේ පුතා. The area is given by this. Hmm? Right. Vertically, one more thing to explain here. First, you take it down. Uh, After that, we can go to example after explaining one more thing. No, continuous nothing into it can be. I think continuous වෙන්න ඕනේ. It's the main requirement to discuss about anything. එහෙම තමයි මේක වලට මේක දාන්න. ඒක මොනවා සෙට්මන්ට් කරනවා. ඒක බැලුවා. ඔයදී මොනස් කඩාය යනකොට ඒක අර පාට මෙහෙම උඩින් යනවා තව පාටයක් දෙකලා තියෙනවා නම් ඒ කොනොක්ස් ඒරියා වලින් දෙන්නේ නැහැ නේද රෝගිලේ නේ බැලුවම අපි ටිකක් විනාඩි 10ක්වත් වැඩියෙන් ගමු අද ලබන සතියේ අපි බලමු පාඩම් දෙකක් කරලා. ගණන් ගන්න එක නෑ ඉතින්. Right. There is one special thing to mention here. Again, something you remember when we did VT graphs. Here, if the graph is on above the x-axis, the area is positive. Area is equal to distance, again equals to displacement. But if the curve is below the axis, area, the curve gives a negative value. So the displacement is equal to not equal to the area. Displacement is equal to the negative value of the area when the curve is below, right? If the curve is above x-axis, this integral gives exactly the area. If the curve is below the x-axis, y values are negative. So finding the integral, you get a negative value. So to convert it to that into the area, you have to take the minus of that. I'll explain it with the diagram. So we'll write it as a note. Note if the curve is below x-axis, so it looks like this. The curve is below x-axis, say from C to D, y equals fx. You take a column somewhere here at a distance x, a column AB like this of delta x. Now this y value is negative, right? You take a similar column as you have taken the previous one. So earlier we said area of the column AB, earlier we said it is equal to y delta x. Is it valid now? This area of the column equals y delta x. This time it is not so because y is negative. So in I write when x is between C and D, y is less than 0, right? So in that case, area of this column is not equal to y delta x. It should be equal to the negative of this. So the area we say under the curve, still we say under the curve, right? Then so above the curve, so namely area enclosed by the curve and OX and OX axis between C and D. C and x equals C and x equals D is equal to not sigma y dx, but it is negative of sigma y delta x as x goes from C to D, right? Or it is equal to not just the integral, definite integral, but it is equal to negative of the definite integral y dx as x goes from C to D. The ultimate y we can replace y by fx. So finally, it is equal to minus fx dx as x goes from C to D. Hari, aku kerjakan dulu. Baru example apa? If the curve is below x-axis, the area is given by minus of the definite integers. Approximately, approximately. Not directly. Atas pakai kena pulang dan kamu kau ini fisik saja. Okay. Okay, so paano mo lang dito? Dahil kumawa daw sila. Saya sudah kira kita அடுத்த line, shall I give an example? An example now. We see how far we can discuss it. The example will consist of many parts, so I'm going to give you a question right there. But I can explain almost all the possible cases, all the possible ways that we can use this method, right? In one problem, I'm going to explain all this. So, example 1. Find the area enclosed by the straight line, the straight line y equals 2x plus 3 and part 1 coordinate axis number 2 OX axis x equals minus 5 and x equals minus 3 OX axis x equals minus 3 and x equals 2 y axis y equals 4 and y equals 7 y axis y equals 1 and y equals 2 y axis y equals 2 and equals 7 y axis and the straight line y equals minus 2x plus 7 and finally OX axis and straight line y equals 2x the same minus 2x plus 7. Diagram kan part එක දෙකක් හරි කරමු. Paling parts the both of it. Paling part එක කරමු. So you can get some idea, you can at least try this. Okay, shall we start with the first? You had to draw a diagram for each part, right? Separately. මෙලින තු කරන්න උනා. එකක් දෙකක් දැන් මාත් එක කරමු. මෙහෙම කරමු. මම පාර්ට්ස් දෙක තුනක් කරගෙන යන්න. ඔයගොල්ලෝ බලාගෙන ඉන්න. ලියාගත්ත නැත්නම් කමන්නේ. නේද? අපෝ බලලා ලියන්න බැරිය. නේද? වීඩියෝ එකේ තියෙනවානේ. Answer. Part 1. You have to draw a diagram as I said for each part. It's a straight line. Y equals 2x plus 3. Y intercept is 3. X intercept is minus 3 over 2. Right? First part, you have to find the area enclosed by the straight line and two coordinate axes. Two coordinate axes, that is this triangle. Area of this triangle we need to find. Area OPQ. Okay, the first part. So as we explained earlier, we take a column. We take a column at a distance x of breadth delta x at a distance x of breadth delta x. Area එක නමක් නම් column එක AB, column AB. Right? ඔයට වඩා හීනියට ඔයගොල්ලෝ පේන පොඩියට නෙමෙයි හරි කොටියක් වෙනකොට හීනියට අඳින්න එක. Consider, you have to write down it, right? Consider a column AB at a distance x from O00 of which with of width delta x. Now, area of the column AB. Area of the column AB is approximately equal to approximately equal to y delta x. So the required area is, now note that this time in this area y is positive, right? So I directly wrote y delta x. So the required area is the summation of such columns as x goes from, to cover this area, x will go from, to cover this area, this x will start from minus 302 and will go up to 0. Yes, from minus 302 to 0 to cover this area. That's where x behaves. X equals minus 302 to 0. Adi, neha lazy wada. Mami nikan kala penna nadanne ekai. And in our method we said this is what given by the definite integral. Definite integral y dx එක තමයි අපි explain කරන්න නැතුව ලියන්නේ, right? minus 302 to 0. Then y to integrate, you can integrate y with respect to x. Replace y by 2x plus 3. This is to integrate. Y is replaced by 2x plus 3. Then find the integral. Find the definite integral value. So that will be x squared plus 3x as it goes from minus 302 to 0. 0 then minus 0, ne? Minus 302, 0 plus 0 minus 302 then 9 over 4 minus 9 over 2. So you get 9 over 4 is the area. That's what you get by the integral. Then second, if you are going to get this exact area by this, because we neglected a part. We neglected a part, right, of the column area of the column AB. So with the effect of that, if this gives with some big error, there can be a doubt inside. No? So you can check. What is this area? It's a triangle. Half into base. Base is 3 over 2 into the height 3. So you get 904. Exactly the same answer. Neglecting that part does not affect, right? මම ඔයගොල්ලන්ට තේරුම් ගන්න පුළුවන් පොඩි එක්සැම්පල් එකක් දුන්නේ. ඊට පස්සේ මේ වගේ ස්ටේට් ලයින් නෙමෙයි අපිට පස්සේ ලොකු ලොකු ඒවා කරනවා. ඊට වඩා වෙනස් ඒවා. දැන් තේරුම් ගන්න පුළුවන් වෙන මම මේ පොඩි එක්සැම්පල් එකක්. Right? So you get the area very nicely by the integration. මේ තව එකක් දෙයක් මම ටක් ගාලා මොකද කරන්නද බෝඩ් එකේ? ඔයගොල්ලන්ට මේ පස්සේ ලියා ගන්න පුළුවන්. Part 2. This time you are the same straight line. You have to draw another diagram, right? This time you are asked to find it as it goes from -5 to -3. -5 -5 to -3. This is the area that we need to find. So we take a column similar to that at a distance x. We take a column AB. This is the y coordinate. And what is the difference here? May have a real now. I had a million now. Consider the column maybe at a distance x from 0, 0 with of breadth delta x. So in area of AB, column AB is approximately, this time we write, do we write y delta x? No, this time it is below the x-axis, right? Y is negative. So we write minus y delta x. Minus y delta x. Right? So the required area is the summation of such such areas as x to cover the required area. X will go from -5 to -3. X goes from -5 to -3. So it's minus, this is replaced by the definite integral y dx minus y we not dana to integrate we write y equals 2x plus 3, right? So we write 2x plus 3 dx as it goes from -5 to -3. Up integrate karo minus, this gives x square plus 3x as it goes from -5 to -3. Value देखो है मुझे अपने minus 60 out. 3 will give 9 minus 9 minus, we apply -5 I'll give 25 minus 15. Make it minus 10. Finally, it is plus 10 the area. හරි. ළමයි මම කොහොමද තව එකක් කරලා පෙන්නන්නද? මේ එතකොට ඔයගොල්ලෝ ඉතුරු ටික try කරන්න පුළුවන්. හ්ම්. පස්සේ ලියා ගන්නත් පුළුවන්. උදේට නැගිටලා පාන්දර එකමාරට විතර නැගිටලා night time data වලින් බලා ගන්න. එතකොට මොනවාද? බකමූල හුම් ගන්න ගත්ත. වවුලු පියාඹන ගත්ත. ඒවත් අහගෙන පුළුවන්. night time data දෙන්නේ බකමූල වලට වවුලු වලට. බෑට යන මොකද කල වැද්දට. උත්තනේ part 3 we have to go from x between the straight line or x-axis and x goes from minus 3 to plus 2. Minus 3 to plus 2. Minus 3 is somewhere here. මට මේක තමයි කියලා දෙන්න ඕනේ. Minus 3 to plus 2. So what is the difference when you take this compared with the previous ones? The part is y in this section, y is below the x-axis. In this section, y is above the x-axis, right? So in this section, when you take the column area, you will have to write minus y delta x. From as x goes from minus 3 to minus 3 over 2, it has to be minus y delta x. ඕක කොලම් දෙකක් ගන්න ඕනේ. එකක් අරගෙන පැහැදිලි කරමු. මෙහෙම එකක් ගමු. Column AB at a distance x of width delta x. Say this height is y, right? Or we did a may vistor area. But when you find the area of this column in this section, y is below the x-axis. So y is negative. The column is y is below the x-axis. So you have to write minus for this part, right? If I total area, you have to take this part separately and this part separately. So it's minus y delta x from minus 3 to minus 3 over 2. Minus 3 over 2. But for the next part, from minus 3 over 2 to 2, it has to be plus. The column is somewhere above x-axis. So you have to take plus y dx. Then me take a makana. Come on, balagan puluhan again. Plus y delta x as x goes from minus 3 over 2 to 2. Basically, it's plus. So then it is the definite integral. This part minus 3 to minus 3 over 2. This part is replaced by the definite integral from minus 3 to minus 3 over 2. Then no minus. It is for this part y dx as x goes from minus 3 over 2 to plus 2. තේරෙනවද ඔය ළමයින්ට? අභීත කවුද සචින් ඉන්න අය කවුරු හරි මේ කරපු දේ තේරෙනවනේ? So the integral you have to break into two parts. One is minus 3 to minus 3 over 2. This part with minus 1 outside. The other part is just 2x plus 3 as it goes from minus 3 over 2 to 2. This is minus 3 to minus 3 over 2. This integral is x squared plus 3x as it goes from minus 302 to 2. ඔක සිම්ප්ලිෆයි කරගන්න පුළුවන් නේ. තේරුණාද ළමයි ඒක? මෙහෙම දෙකට කඩලා ගන්න වෙනවා. You can simplify it මම ඒකට වෙලා යන්න ඕනේ. මට කියන්න ඕන ටික ඔන්න කියලා දැම්මා. තේරුනේ නැත්නම් මේ ටයි අතර බලන්න. තේරුණා නේද කිව්වේ? එච්චර අමාරු දෙයක් නෙවෙයි මම ඒක එකක් ගාලා දැම්මේ. මේ පාර්ට්ස් තුන ලියාගෙන ඉතුරු පාර්ට්ස් 4 5 තනියම කරන්න. homework වලට. එතකොට මම past papers ගණන් හදන්න ඉපන් integration past papers ගණන් හදනකොට පිටු 10ක් විතර අතාරින්න පුතේ. මේක ඉවර කරන්න ඕන. තව ගණන් දෙනවද? areas තව ගණන් හදනවා, volumes ගණන් හදනවා. ඒ ඔක්කොම note එක නැත්තම් මගදී ගැටෙනවනේ. පිටු 12ක් විතරවත් ඉඳ තියලා ඉවර වෙලා integration past papers ගණන්. හරි නේද ළමයි? කාලියට උත්තර නැහැ. තේරුණාද මේ කරපු දේ? නැද්ද? කෙනෙකුද? නැත්තම් හදිසියක් නෑ මට මම ආයෙ එක්ස්ප්ලেইন කරනවා. මොකද උනේ ළමයි? Got any problem? Any question? Okay. මම ඕගොල්ලෝ මේක තේරුම් ගන්නම අරනේ මම ඒක එකකට කරලා දැම්මේ. පොඩි දෙන්නේ ඉන්ටිග්‍රේෂන් කරන් පස්සේ. එහෙනම් අපි උතනින් නවත්තමු. ඔය ගණන් ඔය පාර්ට්ස් ටික හදලා තියන්න ඕනේ. right පාර්ට්ස් ටික හදලා තියන්න. අපි අනිත් දවසේ areas ගණන් හදලා ඉවර කරලා volumes මේක ඉගෙන ගත්තාම පස්සේ volumes බොහොම ලේසියි. finding volumes ඒකත් ඉවර කරන්න පුළුවන්. කොහොමද ඉවර කරනවා ලබන සතියේ? calculus. right? එහෙනම් අපි අද උතනින් නවත්තමු. ආයි ඉරිදට නේද ක්ලාස් එක. සෙන්සුරාදට තියෙනවානේ. රිවිෂන් එක. හොඳයි. එහෙනම් එදාට හම්බෙමු නමයි. බුස්සර්ණයි. good night. That one. Korea.